20.
20, right? So if you have 20, what happened is we started at 0 and we increased it all the way to 120. That's like 6 times the difference. So that's not very good. So the reason what we need to do is we add on something called a learning rate. So learning rate, if you take the gradient, so the gradient is going to be how much you update. So you remember this update function over here? We're gonna multiply this by some constant, okay? This constant is gonna be called alpha, which is the learning rate, okay? So using this learning rate, we're going to, let's just, so over here, if we had a multiply by a constant, which is the learning rate, what do you think the learning rate was in this case? Like it's not here, but
6.
no, not 6. Okay, so you know how we just put a negative. So technically over here, we're multiplying by -1 of the derivative, right?
Mm-hmm.
So technically the learning rate over here is 1, okay?
Okay.
The learning rate here was 1. Like there's an imaginary 1 over here.
Wait, were you asking like what the learning rate is right now, or what are we supposed to have the learning
Right
rate
now,
be?
right now.
Oh, right now, yeah, 1 then.
Yeah. Okay, so what we need to do is decrease the learning rate because we don't want to increase the weight or the bias by that much, right?
Mm.
So what we do is, let's say we're gonna use a value of like 0.0.01, right? So if we use of, okay, so if we change, okay, so this is what we call an optimizer. So if you have a learning rate, it's called an optimizer where you're optimizing to find the lowest value, okay?
Okay.
So the lowest cost. So then here's your learning rate, which is the constant. See, we define the constant in the init method. And then we just multiply by the derivative. So over here, we use a learning rate of 0.01. And then what ends up happening is, this is what ends up happening. See, our original cost was this much, and now we increase by about 61 the weight. And you said the weight should be 10. So we
Mm-hmm.
still increase too much. The bias though, the bias should be 20, but then we increased it to 11. So the bias, we increased the enough amount, right? But then the
Mm-hmm.
weight, I mean, the bias we increased too little, but then the weight we increased too much, right?
Yeah.
So then what you do is we're gonna use 0.01, okay? So if you use a learning rate of 0.01, what ends up happening is here, you get a your weight increases to 6 and your bias increases to 2. Your bias should be 20, your weight should be what's it called? 10, okay? So at least now, if you look at the cost, we have actually decreased it this time
Mm-hmm.
compared to this original cost. So to continue decreasing the cost, you just continuously update the parameters. So if you continuously update parameters, you use a for loop, and then you do this whole thing, okay? And then we're gonna use matplotlib again to plot the cost over time, okay?
Okay.
After each update. And you see, this is what we get. It drops down very quickly in the first few epochs. Like we call each parameter update an epoch, okay?
Okay.
So it
Yeah.
decreased really rapidly and now it's like done learning because it's low. I mean, its cost is about 0, right?
Mm-hmm.
So what you see over here is by the end of 1,000 epochs, our weight has become 10 and our bias has become about like 20 and our cost is pretty small now. So
Yeah.
we can say that the model here has learned. It is smart now. Okay. Okay.
Interesting. Okay.
Yeah. Okay. So the problem here is that we had to do it 1,000 times. So it's slow at training models. So this optimizer is slow at training models. And we have less than a minute left, so I'm gonna just speed run the rest, which is really little. So we did it 1,000 times and it's really slow. And then the weight, if we plot the weight over time as we're updating, first few epochs we updated way too much, and then it slowed down, and then it slowed down learning, and then the bias has increased pretty goodly.
Yeah,
Okay, so
Goodly?
we have less than a minute left.
Goodly.
it's fine. Just
I'm back.
Yeah, so it's technically work.
Aiden, we have
so
like
the-
2 minutes.
No, only
Oh,
less
really?
than a minute.
Damn.
So
what
what
do-
we're gonna do
It
next
is.
meeting is that we're just gonna fix these limitations. You see how the bias should have increased more, and the
Yeah.
weight